Hello guys, welcome once more to another video on our YouTube channel. My voice is not really the best, but I just I just want you guys to pay keen attention. Maybe my volume might be a little bit low, I don't know, but guys, just pay keen attention. So in this video, right in front of me there is a question I found in the Northwest Regional Mock 2019. It's on linear transformations, and I'm just going to write down the necessary informations. So we have a linear transformation T, which is from arrow cube. So arrow cube, and they have actually given us a matrix of transformation. The matrix of transformation is 2 minus 1 4 3 2 5 1 3 1. Voila, that's a matrix of transformation. So the first question is that we should find my handwriting might not really be the best because I'm writing with my finger. You realize that most of my videos I don't write, so yeah, I'm writing with my finger. So because I'm tired of doing a PowerPoint, so just bear with me. Find the image of the point 775 under the transformation T. And then the second question is that we should find the Cartesian equation of the plane, which is the image of the whole space. So maybe find the image of the whole space. All right, so that is a question. So for those of you guys who are maybe copying, you can get it down so that I move to the next slide and we get started. All right, so let's move on to the next slide. Okay, so the image of a point under a transformation is basically defined by the matrix, because every transformation T will map a certain point. Okay, this X is actually maybe a certain point. Wait, let me use the point A. So it's going to map the point A. Okay, it's going to map the point A to a certain point B. That is, sorry, the image of the point A is the point B, and the point B is actually gotten by taking the matrix of transformation times the point A. That's how we find the image of a point under a transformation. So if I want to find the image of the point 775 according to the first question, then I'm just going to call the image maybe x prime, y prime, z prime, and it is equal to the matrix of transformation 2 negative 1 4 3 2 5 and 1 3 1. We take it and we multiply by the point 775. So guys, let us do the matrix multiplication. So x prime, y prime, z prime will be equal to, here I don't know, there is no laser present. How will I explain this? Anyways, we need to take let me see, we need to take 2 times 7 plus negative 1 times 7 plus 4 times 5. 2 times 7 is 14. Anyways, I'm just going to leave the matrix multiplication to you guys. I think if you're doing further math, it's not supposed to be a hard nut to crack. So just do the matrix multiplication and give me your answer in the comment section. What I am more interested in is, how do I find the Cartesian equation of the plane, which is the image of the whole space? So the whole space is actually xyz, all right, because here we are in arrow cube. My transformation was actually from space arrow cube to space arrow cube. So I want to find the image of arrow cube under my transformation. And if you are a point in image, just means that I need to find the image of all points in space, and any point, all points in space will be represented by xyz. So the image of any point in space, okay, let's call the image x prime, y prime, z prime, will be equal to the matrix of transformation times that point. Okay, we need to take the matrix of transformation times a point. So the image of x is x prime, the image of y is y prime, and the image of z is z prime. All right, so let us do the matrix multiplication. So we just equate directly. X prime will be equal to 2x minus y plus 4z. Now y prime will be equal to 3x plus 2y plus 5z, and z prime will be equal to x plus 3y plus z. So what we need to do here is that we need to find an equation in terms of, in fact, the equation of the plane is kind of supposed to be in the form ax prime plus by prime plus cz prime equal to d. That's the equation of every plane. So if we are able to have an equation of this form, then we have succeeded in getting the image of the entire space. So I'm just going to recopy what I have here in the next slide. So we had that we had x prime to be equal to 2x minus y plus 4z. We had y prime to be equal to 3x plus 2y plus 5z, and then we have z prime to be equal to x plus 3y plus z. Voila, this is what we have. So what do I do next? You realize that now this is actually for, if you are not able to think, it's going to be very complicated for you, believe me, because we need to eliminate x, y, and z totally from these three equations and link up x prime with y prime with z prime. That's what we need to do. So you just see that if I call this maybe equation 1, I call this equation 2, and I call this equation 3. Let us see. If we take equation 2 minus equation 3, we are going to have equation 1 clearly. So if I take equation 2 minus equation 3, I am going to have y prime minus z prime to be equal to 3x minus x is 2x, 2y minus 3y is minus y, and 5z minus z is plus 4z. But you realize that this quantity is basically in equation 1, and it is what? It is x prime. So it therefore means that we have y prime minus z prime equal to x prime. Okay, so I now need to write it in the form I give you. So I need to send everything to the right hand side so that I get x prime minus y prime plus z prime equal to 0. So this is the equation of the plane. So the image of the whole space, the image of the whole space, the image of the whole space under the transformation T is the plane x prime. No, please, we don't need the prime again. Is a plane x minus y plus z equal to 0. So that is it. All right, so the video is already 8 minutes. I think we are going to end here for this video. Stay tuned for more videos. Thank you for watching, guys. See you in the next video.